For the past 2 days, we have been tracking a swarm of earthquakes that started near Mount Shasta in California. And though they are continuing to happen, there is some good news and some bad news. The good news is that no major cities were affected by these quakes. The bad news is that we don't know why this swarm suddenly started. Hi, it's me, and this is my channel. And I am definitely going to get back to telling you about space stuff. But while I'm waiting for the next coolest picture from the James Webb Space Telescope, I have decided to spend a little bit of time talking about something that affects us here on Earth. And if you have been following along on social media, you know that we have been tracking this earthquake swarm since they started. This swarm has now produced over 500 earthquakes, but the vast majority of them have been small ones. Only 40 of the quakes were magnitude 3 or greater, and only 5 had a magnitude above magnitude 4. The largest was a 4.6. So overall, while there have been a lot of earthquakes, the energy released by the entire swarm has been equivalent to about half of a typical moderately sized earthquake. But even so, we didn't know why they were happening or how long they would continue. It's been raining in the area, so that likely ruled out the most common cause of small swarms, which is typically dry hot steam escaping from a deep underground reservoir and causing small explosions of magma below ground. You see, when magma heats up water underground, the water turns into steam and expands, increasing the pressure until the rock breaks and releases gas, and sometimes even a small amount of magma. That event is called a phreatic eruption, and they can be pretty dangerous because if the explosion happens at shallow depth, the rock can blow up to the surface and release things like volcanic ash and fine rock particles into the air. But that is not what happened in California because, well, the ground was already wet. In fact, much of the western United States is covered by what is called the Pacific Ring of Fire, an area where tectonic plates meet and interact with each other. Most of these interactions result in volcanoes, including Mount Shasta. Mount Shasta is a volcano, but right now it is quiet. Its last eruption happened between 1786 and 1825. So anything happening beneath the surface right now probably isn't related to the volcano. And that brings us to another possible explanation for the earthquakes, something called induced seismicity or human-caused earthquakes. Human-caused earthquakes are typically caused by the movement of large masses of water underground. And if you're trying to figure out what might be causing it, there are a few possibilities. There are natural hot springs in the area, and there are geothermal plants nearby that pump hot water from below ground to the surface. Then there are also reservoirs created by dams upstream. These reservoirs contain enormous amounts of water, and when you dump that much weight onto the ground, it does tend to make the ground shake a little bit. There was a paper published in 2009 that studied the effect of filling up the Trinity Lake Reservoir on earthquakes in the region, and they found that after the reservoir was filled, there was a marked increase in the number of earthquakes in the area, especially those larger than magnitude 2. The researchers estimated that the reservoir contained enough water to increase the local seismic activity by about 25%. But they also found that the effect of the reservoir was limited to the area immediately surrounding the lake itself. Yet the earthquakes in the latest swarm were felt as far away as Bend, Oregon, a distance of about 200 kilometers. Not only that, but the earthquakes didn't start when the reservoirs were filled. They started decades later. Something that could explain this is called delayed time effects. In this case, the water pressure from the reservoirs could have taken decades to build up enough to trigger the earthquakes. However, another recent study published in 2022 claims that there is no relationship between seismicity in the region and the water levels in any of the nearby reservoirs. Basically, they looked at all the historical records of water levels and compared them to the timing of earthquakes and found no correlation. What both studies do agree on, however, is that the most active seismic zone in the region is close to the edge of the largest reservoir. So that makes it seem like there could be a connection between the two, even if it's not a straightforward one. So maybe this latest swarm was caused by all that water. Or maybe it wasn't. The point is, we just don't know. Earthquakes are fascinating and beautiful in their destructive power, but they can also be incredibly dangerous. So scientists take them very seriously. However, part of the challenge is that they are impossible to predict. There are lots of ways to try to forecast an earthquake, such as looking for changes in the frequency of small earthquakes that may indicate that larger earthquakes are brewing below the surface. But no matter how much data scientists collect, they cannot say with certainty that a large earthquake will not happen for hundreds of years or that it won't happen tomorrow. Because of that uncertainty, forecasting earthquakes is very difficult. And despite a lot of effort, there have only been a few successful predictions of large earthquakes before they happened. The best example of an earthquake prediction came in 1975, when Chinese scientists predicted that a large earthquake would strike the Haicheng region of China within a week. Scientists from around the world were skeptical, but just 7 days later, a 7.3 magnitude earthquake struck. Unfortunately, this was followed by a series of even larger earthquakes that killed at least 260,000 people. So while predicting earthquakes can save lives, it doesn't always work. And if you can't predict when an earthquake will happen, then you can't very well pinpoint where the next earthquake swarm will occur either. Because of that, scientists can't say with certainty what caused the recent earthquake swarm near Mount Shasta, though I do have a theory. When I heard about this earthquake swarm, I immediately wondered if it was connected to the recent heavy rains that pummeled the region. California has been experiencing a huge atmospheric river event. Basically, there has been a lot of rain falling recently. According to some reports, parts of California have received more than a year's worth of rain in just a few weeks. This has led to dangerous flooding and landslides in many areas. My initial thought was that perhaps the ground shook because the water table rose. When water fills the cracks in the rocks underground, it adds weight that the rock layers above it have to support. Maybe the weight of all the new water pushed down hard enough on the rocks below to cause them to break and produce earthquakes. After all, the 4.6 magnitude quake occurred soon after a huge rainstorm. However, the water table rising wouldn't explain why the earthquakes continued for 2 weeks after that big storm. Well, here's my theory. All that rain went somewhere. Even if the water table didn't rise where the earthquakes were happening, the water likely made its way underground into the aquifers below, and when it reached a certain depth, it started pushing against the rocks in a way that caused them to break and produce earthquakes. To be clear, that is just my theory. I am not a geologist. I make videos about space, but I do have some experience with groundwater. In my previous job, I worked for a company that helps clients assess the risk of flooding and earthquake-induced landslides. We use computer models to simulate how water moves through the ground. And based on the types of rocks present in the area, we can calculate whether that water will eventually make its way into the aquifers below. And in the case of Mount Shasta, I would bet that it does. My geology colleagues tell me that the rocks in the area are highly fractured, which means that the water has lots of places to go. The thing is, once it gets there, it can sit there for a really long time, decades even. So while we can't prove that the earthquakes were triggered by all that water, it does seem logical that the heavy rains in California would eventually make their way underground and cause some rumbling in the rocks below. Whatever the cause, though, swarms of earthquakes are usually not something to worry about. Yes, there were some larger ones mixed in with the smaller ones, but the largest was still less than a magnitude 5. Anything above a magnitude 7 can be devastating. So this swarm of earthquakes did not pose a major threat. It's also worth noting that swarms of earthquakes are often harmless. For example, there was a swarm that hit Napa, California in 2014. That one produced almost 2,000 earthquakes, but none of them were larger than a magnitude 3. So it was more of an inconvenience than a disaster. What is strange about the California swarm is that it is still continuing. While it has slowed down significantly, the swarm has not officially ended. According to the United States Geological Survey, a total of 528 earthquakes have hit the area, and while 491 of them were smaller than a magnitude 3, 27 of them were larger than a magnitude 3. In general, swarms of earthquakes subside after a few days or weeks, but this one lasted for nearly 2 weeks and is still going on. Maybe it will keep rumbling for a few more days or maybe a few more months, and until it stops, we won't know exactly what caused it. But I hope I was at least partially right. Thanks for watching, and thanks to my supporters for helping me pay for the high-speed internet connection I need to upload these videos. If you want to help me make more videos like this, you can join my membership program today, and if you want to watch more of my videos, you can do that too.